uh, start rolling. So I'm happy to welcome everybody today. So today we'll be talking about pitfalls while starting your serverless journey, and we also cover a little bit of Azure Functions. If we could move further with the slides, it will be easy for me to follow up. Thank you, Josh. So we have two folks talking today. It's pleasure, Josh, to have you here today, and we have also Adam. So, Josh, if you could tell us more who you are, what you are doing, and why we get you here, it would be
sure.
Helpful.
Yeah, and thanks for having me. So my name's Josh Carlile, and I'm actually based out of Raleigh, North Carolina. We were just talking about time zones, right? So I'm on the East Coast of the US. I'm a Microsoft MVP on the Azure side, but I've spent most of the last 20 plus years in miscellaneous developer and architect roles. So that's kind of my background, but probably half that time spent has really been in the cloud. And the last few years has especially been focused around serverless and more specifically around Azure Functions, but serverless in general, right? And that's where I kind of spend a majority of my time with the community and having kind of conversations like this, right? But for my day job, I'm actually a principal cloud architect with Zscaler, which is a cloud security company.
Yeah, and as I remember, you have pretty extensive usage of Azure Functions in your workflows.
Yeah, absolutely. So obviously, Azure Functions is part of my day job as well, and I've actually been working with serverless since Azure Functions first got released. I was a beta user, and I've used it very successfully with lots of small and very large customers over the last few years. So. I'll be sharing some of that experience, maybe a few of those little war stories, right, along the way here for the next 45 minutes.
Perfect. So, Adam, what about you?
Yes.
Few words.
Yes. So I'm the Chief Technology Officer at RevDeBug. So we basically designed a observability platform. Most importantly, we actually came up with reverse debugging technology that can be used with Azure Functions and other cloud native technologies. So just to make it easier to troubleshoot and debug applications, even basically from when you get some production errors. Yeah? So I'm writing software till I was basically a little kid, and debugging and troubleshooting, that's basically most of my life. So that's also why we have came with the idea how to make this part of our coding lives easier. So that's my background.
Oh yeah, I think you have similar experience as Josh, like 20 years or so.
Yes, 20 plus years enterprise software development, with many large customers, down on IKEA, ArcelorMittal, Philips Thomson, and other like that, with basically lots of technologies, not only Microsoft, but mostly Microsoft, Microsoft.NET, C#, and of course Azure Cloud as well. Yeah.
All right. So just a quick. All right.
Oh, sorry. I was premature click there.
Don't worry, I could follow up it easily. So we'll do a quick overview of what are the serverless, where to start, what are the common challenges, and what people are missing and forgetting when they are deploying serverless, and why it's crucial. So it's monitoring and visibility. And later on, we have few technical examples. So if you have any questions, you could type them in the chat or in the Q&A part, and we'll be following with those questions during the presentation or after the demos. So, Josh, let's start.
So obviously the question is, what is serverless? Why should I care, right? And as I mentioned, serverless in its current form has really kind of been around for the last 5-6 years. And there's different vendors, right, for serverless. Azure Functions, AWS, GCP has its own, right? And some of the definitions and some of the values that you hear might be a little bit different based on the vendor, right? So it's useful to kind of, in my mind, really to to define this back to some of the foundational elements, because some of those foundational elements are going to help you understand why you should care, right? So the first thing to understand is this is a fully managed platform, right? So serverless should be a fully managed platform. And that largely means that you don't have to worry as much or really any about a lot of those infrastructure details that support running your code, right? Now, there is, of course, kind of a spectrum here, right? But at the end of the day, if you're worrying about individual virtual machines, or you're having to spend a lot of time considering how to make use of them, then you're not really talking serverless here, right? So one of the first tenets here is it's a fully managed platform, right? The second piece here is that's important is the automatic event-driven scale. So when it comes to serverless, we have this concept of rapidly scaling, right, in response to events. Those events can be something that most folks think of, like HTTP events, like if you have an API, an HTTP request coming in. So the more requests coming in, the more you scale. But it's also include other types of events, things like messaging, right? Messaging platform. So it's really event-based, right? Scaling. And just as importantly, though, is scaling up is scaling back down, right? And ideally, and eventually scaling back down to zero, right? If you have no events. So you shouldn't need to have compute out there and the costs associated with that, which we'll talk here in a second, if you're not doing anything, right? If you're having, once again, to do a lot of work around figuring out how many instances you need, maybe having to pre-provision stuff ahead of time, right? Because you're anticipating a big load, then once again, you're not talking serverless here, right? So automatic event-driven scale is the second part. The third part, and I kind of alluded to this a little bit, is really you only pay for what you use. So you're not paying to keep the lights on, right? So this cost model for serverless is really important. At the end of the day, you're only paying for what you use. So in practice, it's typically some sort of combination of the number of requests that are coming in, so you're paying per request, and the amount of resources that request uses. It could be CPU, it could be memory, kind of a little bit different based on the cloud provider. But it's all of those add up to how much your request consumes. So in the case of Azure Functions specifically, right, that traditional consumption plan, which is that serverless model that we all like, you'll pay per request. And I think it's something like 0.0000, a bunch of zeros and like a 1/6, right? So you're talking fractions of a penny. And then you're also paying for a gigabyte a second, right? And so that's kind of a measure of the compute. So how much memory did you use for that request? So it's a little bit of an abstraction there of those concepts. But one of the nice things, for example, about Azure Functions specifically is that you get a really generous free grant. I think it's these days, it's around 400,000 gigabyte seconds quota that you can use and around 1 million executions a month. And why this is so interesting is that, especially for folks who are just starting their serverless journey, right? If they just want to kick the tires, or maybe they have a little mini project they want to do, and I'll talk about some kind of low-hanging fruit for that. But for a lot of those use cases, you will pay next to nothing, right? So it's really easy to kind of get started because those costs are so low. Now, it's worth mentioning that there are some additional storage costs associated with Azure Functions. When you deploy your code, right, it has to live somewhere. But generally speaking, if once again, you're in that scenario where you're in that free grant and you're just running stuff for free, your storage costs will likely be pennies, right? So obviously anything at scale, right, can cost more. But what this means for people getting started, right, is that there's a very, very low barrier of entry, right? But so how do these kind of three kind of core tenets really kind of translate to, sorry about that. Apologies. How does it really kind of translate to why I should care, right? So, well, it really comes down to what this model means for the development cycles, right? So in general, across serverless, because you don't have to worry about all the infrastructure and those other platform details, you're generally kind of razor focused, right, on the code that brings the most value, and that you can continue to iterate quickly, really kind of on that valuable code, release after release, right? So it's that velocity, right? It's that developer velocity that is the part of why you should care. All of these aspects add up to increased developer velocity. Now, specifically in the case of Azure Functions, Azure Functions actually has some aspects to it that beyond just those base serverless attributes, right, that add some additional developer velocity because of that Azure Functions runtime, they introduced some concepts, something referred to as bindings, that really are all about taking care of common boilerplate, common code for you, right? So that, of course, speeds up your velocity. And additionally, like there's a lot of common elements that we'll talk about here as well around workflows. And Azure Functions has something called durable functions that kind of help you build these complex workflows. And at the end of the day, kind of important for developers as well, is there's a great local development experience and developer tooling that makes developing with Azure Functions really easy. And that's a little bit of a departure historically from some of the other serverless platforms as well that didn't have as much of a developer experience. And that was originally, if you've kind of been in and heard about the serverless space for a little while, that some of that experience wasn't really well done. Well, in the case of Azure Functions, it was actually very well done from the get-go. So these are kind of why you should care, right? Because of that velocity. Because at the end of the day, once again, you're focusing on the code that matters, right? Not all this extra stuff, right? So that's why you should care, right? And some overview really of the serverless platform. But where do you get started, right? What are some of those? What's that low-hanging fruit here, right? What are the opportunities that you may have to get started? Because it can kind of be overwhelming, especially if you don't have a given greenfield project where you're like, hey, I need a developer, go do X, Y, Z. Where can you start getting? Where can you start your serverless journey, right? Well, I'll share first off where I got started, and also a common place for a lot of other folks to get started. And these are scheduled tasks. So Azure Functions has this concept of a timer trigger. So this trigger concept is something you'll hear over and over again. As a trigger is something you're responding to an event. So in this particular case, you're responding to an event that runs like a cron job, right? Now, in my case, I actually, in a previous life, worked a lot with like backend integrations with SharePoint. So kind of surfacing a lot of enterprise data through custom APIs and things like that. Things like SAP, what you'd expect from a corporate world, right? It was very common to kind of surface that information through SharePoint. And it had, to support those operations, we had a lot of scheduled tasks. In SharePoint world, it was something called timer jobs, right? But as customers started to move to Office 365 and started to kind of dabble in the cloud a little bit, we still needed to have those integrations, right? Those integrations were still really important, but we no longer had any place to run them because we no longer own the servers, right? And so what we ended up doing is using Azure Functions to move those short running but very important tasks over to Azure Functions. And at the end of the day, we didn't have to spin up a lot of expensive VMs, right, to support something that runs for a few minutes a day, a few minutes a week, or even a few minutes a month, because sometimes something that runs a few minutes can still be super important. So we were able to kind of port a lot of that logic over to these functions. In our case, we did them in C#, but there's a lot of other languages that Azure Functions supports, right? So we that was kind of my first foray, and my experience there led me to really be impressed with the service platform and kind of expand on it. Now, if we take it a little bit more towards today, another commonplace, some low-hanging fruit, right, for Azure Functions is to support static website APIs, right? And so, you know, in the last 10 years, there's been this shift, right, from traditional, you know, from traditional web servers, right, like your ASP.NET, your Java, you know, your PHP, those traditional web servers, to more of a client-side model, right? Things like React and Angular, right? And even more recently, some of the WebAssembly stuff, things like Blazor, right? And there's a lot of benefits around that. All you have to do is deploy that static content to a content delivery network. You don't need big, expensive web servers. It's easy to distribute. But what you still need are those backend APIs, right? You still need to talk to data. You still need to do logic somewhere, right? So even though you have all this great ability to with the content on the client side, you're still kind of stuck with the old stuff on the server side, right? And so this is a natural alignment for serverless APIs, right? To be able to provide that API layer for all the static websites, whether they're very busy static websites and they need the scale, or just as importantly, those little ones that only get hit occasionally, those blogs, those, I like hearing the example sometimes of the internal corporate travel sites, right? That haven't seen anything for a year, right? But as soon as travel opens up, they're going to get crazy, right? Those type of things. And interesting enough, from the standpoint of this use case, it's so common that Microsoft and Azure really has come up with Azure Static Websites, which is actually the combination of these static assets that you get through React and these client-side UI frameworks combined, right, with Azure Functions, and all wrapped together with some nice glue that takes care of common scenarios like authentication. But at the end of the day, those static web APIs is a really good low-hanging fruit, right, to be able to make use of Azure Functions, make use of serverless. And once again, we're gonna get all those benefits we talked about a minute ago, right? We're gonna have the scale if we need it, but it's also gonna be really cheap if it's a
especially that if you deploy if you deploy a static statically basically compiled website in React or Vue, you basically pay for the transfer for the first time, and it gets cached on the user side, it's on the web browser. Yeah, so you basically don't incur the transfer costs from the Azure side. Maybe when it will do an update, yes, but in most cases it will just get cached, and so you will not get those hits, and you only pay for the traffic that the usage of the application causes. It's not that there is some runtime that just waits for the user to or all the time serves the same web page. Yes.
Yeah, absolutely. And once again, and in my experience too, folks love them because if they're just infrequently used stuff, you're paying next to nothing between the content delivery costs, which is all cached in the on the browsers a lot, and the very minimal costs around serverless. But it's there if you need it. If you get all of a sudden some spiky traffic, right? Yes. And it's relatively simple to implement. There's a lot of complex patterns that you can use within serverless and Azure Functions, but API endpoints isn't one of them, really, right? So it's some low-hanging fruit. It's a really a good place to start, and it's a very practical place to start as well.
Yeah, and I think this is useful to remember that it could have some kind of delay, cold starts, or this kind of stuff. We talk later, but it doesn't work everywhere. In every case, but if you could have something running slower, it would work perfectly.
Yep, and there's some ways to accommodate. We'll talk about here shortly about some of the challenges, right? Because it's not always there's no easy button, right? As much as everybody would like an easy button, there's some optimal use cases, and but there's always challenges with anything.
No silver bullet,
for sure. Another common pattern here, right? Another common low-hanging fruit is a lot of companies have some sort of message processing, right? They're using queue systems today. Things like in the Azure world, storage queues, service bus, or if they're doing some sort of streaming things, streaming messaging like event hubs, right? They have these platforms out there today, and they have a lot of infrastructure that supports it. These VMs that process all the messages coming in, and they have to figure out how to scale them. They sometimes have to write special code, right, to figure out how to distribute the load. These are natural places. This is, once again, a natural low-hanging fruit to quickly take that and port it to Azure Functions and get the scaling and get out of the infrastructure game, right? And so if you have existing message processing that's going on today, right? This is and once again, going back to the terminology we use in Azure Functions, a trigger, right? Service bus has a trigger, queues have a trigger. That this is some low-hanging fruit to be able to very, very quickly get some value out of Azure Functions and free up some infrastructure and free up some complexity with that. And this is once again very common in serverless across the board, because this is a very async pattern, right? That is very that aligns very well with serverless. It's worth mentioning too is that I mentioned some Azureisms in there, like service bus, that's Azure, storage queues, that's Azure, event hubs, that's Azure. There are some non-native, Azure native triggers as well. Things like RabbitMQ and Kafka are also supported within some scenarios as well. So you're not just limited to just the Azure native pieces. So if you have some workloads out there that may be running on a VM, right? You got a RabbitMQ deployed to a VM in Azure, right? You can still get some value from this. But building on that as well, messaging can get complex. It is often the case where you have messages that tie together a complex process, right? You throw something in one queue, it gets processed, and throws in another queue, and maybe it goes to 3 different processes, and then it throws in another queue, or sometimes you have some bulk processing, things like fanning in and fanning out, like where you have a request and that request gets broken into 100 parts, right? And then you want to use the power of serverless, the power of that parallelization, right? That you can do, that massive scale, to process them all at the same time, right? Some of those things are usually accomplished through messaging, and you may be using that pattern today in your messaging platform, but it gets complex. It gets hard to write, right? And so one of the natural places to start your serverless journey is also around workflows. And you might think, okay, what kind of workflows? Well, almost every app today has some sort of code-based workflows. It could be this fan in, fan out pattern that you kind of see in the picture here, where one request comes and gets broken up, all processed at the same time, and then it kind of gets combined together. But it also could be things like waiting for external events. You might be waiting for a person to click on an email and say, yep, I approve this. All of these kind of asynchronous operations, this orchestration that usually takes place with all these messaging platforms that is inherently complex, can be done and greatly simplified using something called durable functions, which are some extensions built on Azure Functions that allow us to do these workflows. And we'll talk about this a little bit more in a minute here as well. But these are 4 kind of natural places where if you're not being given hey, go build XYZ because we have a new project, and you're just looking for some opportunities to kind of start your serverless journey, these are 4 good areas that you should probably consider, and that you can get some immediate value from serverless and specifically, obviously, Azure Functions, right?
Yeah, and if I might actually add a little bit from my experience, so I actually used the scheduled tasks. That was the first actually usage, because with enterprise software we used a lot of SQL server scheduling functionality that was built in there, basically for years. But when you move this on-prem enterprise SQL server to a cloud based instance, you actually lose that functionality, yes, and you have to replace that. And the trigger, the timer trigger was actually the basically the most straightforward way to do so, yes, to move all of that away. So yeah, just from my own experience, that was just very easy and very low friction to actually move all of that.
Yeah, absolutely. I mean, there's very few developers who haven't at some point in time in their life been given a requirement to, thou shalt write something that executes at 3 o'clock every day, right?
Yeah.
That kind of scenario is so common, whether you're a developer or really at the end of the day, an admin, right? Trying to do some stuff, it all kind of applies.
Yeah, so let's move further, Josh.
Yeah.
Challenges. I have one in mind. Let's see what's your experience. So.
Yeah, for sure. As I mentioned, it's not always all rainbows and unicorns, right? So as much as we'd like that easy button that I talked about, right? Serverless does come with its own set of challenges. And some of those challenges are kind of unexpected, especially for folks who are new, right? So these are kind of some challenges that may kind of impact new folks a little bit more than seasoned serverless folks. So the first one that generally comes up that surprises folks is timeouts, right? So most serverless platforms have some sort of baked in limitation around how long a function can run. So by default, for example, in a consumption plan in Azure Functions, it's 5 minutes. but you can do some configuration that can extend it to like 10 minutes too. But now it's worth mentioning when it comes to this, that Azure Function does have some additional options, right, around dedicated and kind of premium plans that kind of eliminate some of these timeouts. But that, of course, comes at a cost, like everything else. But it's common for developers to port like some existing code, right? Taking that use case that we were talking about where it was a scheduled task, right? They may have a console app, right, that they put in a Windows server and run it as a job once a day, right? And they're like, hey, I just want to take the code that's in that console app and just throw it into function and run it, right? And that may seem like a good idea, right? And they may still be able to utilize that code, but they also may run into unexpected timeouts, because what happens when that code takes more than 5 minutes? What usually happens, and it's been my experience with timeouts, is that a developer is doing something that acts on data. And so they're doing some development scope data. So they're throwing in 10 records and saying, hey, this works great, right? And then it never fails that you throw it into production and someone throws in 1,000 records in there, right? So at the end of the day, they can folks can have some unexpected timeouts, and that usually means they need to refactor to break down some of that task into smaller pieces. But this often can come as a surprise, because they think they can just throw whatever code into an Azure function and it's just going to work. And sometimes you're lucky enough that it does do that, but sometimes it does do some refactoring, and sometimes it comes as an unexpected challenge, right? When you're just getting started with Azure Functions and serverless. This next piece here was alluded to already, but this is cold starts, right? I think anybody who's heard anything about serverless has heard the word cold start, right? But cold starts really happen when there's no compute running. So if we remember, I talked about earlier, we want to scale down to 0, right? We don't want any compute running because we don't want, that's how serverless becomes so cost effective, is that there's nothing running, right? There's just kind of a control plane listening for messages that's managed by Azure, but there's no actual compute running there. So what happens when a request comes in and there's nothing there to handle it? Well, that's when we get a cold start. Now, for things like messaging and asynchronous type of triggers, it's not really a noticeable thing, right? If it's already asynchronous, you're not going to notice a few seconds, right? Or a minute, whatever it may be. But where you will have maybe a poor experience, and I think Adam kind of alluded to this a little bit with some of the static web apps and using those APIs, is when you're tied in with something that's latency sensitive. That's usually UIs, but there can be other scenarios there as well, right? But where at the end of the day, someone goes to the API and nobody's hit that site. It's that morning use case. And, you know, the first worker coming in at 8 in the morning, right? And they go and they hit your site because they have to do something important on the site, and it's spinning. And so what do? They're like, they open up a ticket saying, hey, this is slow. This is unusable, right? Well, that could just be a cold start. That could just be that first hit and nothing's warmed up. So now I think that this was a bigger deal when serverless first started. But really the cloud providers have gotten pretty good. They've gotten a lot better at dealing with cold starts, right? And there are horror stories that you hear from the early days of serverless, quite frankly, especially with Azure Functions. You could be waiting minutes, not even just seconds, but minutes, right? And so we don't really have those scenarios today. Everything today, and it kind of depends on the use case, is sub-second. But it's important to understand that, because at the end of the day, if you have that low latency requirement, and especially when it's tied to a user experience, then you could have some of those cold starts, and those cold starts could lead to random help calls. Hey, this is running slow, and then you go check it out and you're saying, hey,
Josh, are there differences between languages? Because I know there's difference between platforms, and yeah, this is also
no, that's a great question. There is difference between languages, and there is difference between use cases within languages. So unpacking that a little bit, historically, for example, Node would have NPM packages, and the first time everything spins up, it may need to pull down NPM packages, right? So sometimes, for at least for Azure Functions in general, Node could have potentially a larger cold start than other platforms. And once again, there's workarounds, there's optimizations that you can do to this, right? And pre-compiled, like .NET always has been a first-class citizen on Azure Functions, and a tightly compiled .NET Azure function is likely going to have less cold start, less spin up time, right? But even within those, if you have code that has heavy middleware, right? So there's heavy startup requirements, right? When things spin up, it needs to load up a bunch of stuff. Maybe it loads up cache, maybe it loads up other things, right? So part of it is some language-based pieces, but part of it also is how how you built the code. But I will mention one thing about this. In almost all the cases, there's workarounds for this, right? There are things where you can use that timer job, right, that I talked about earlier, to touch your API every 20 minutes, every half hour, just once, a keep alive at the end of the day, right? Interesting enough, there in Azure Functions, there's also some premium plans where you can, it's a little bit of a hybrid, right, between serverless and traditional compute, where you can have some pre-computed, pre-warmed rather, instances kind of sitting around waiting for you. Obviously, there's a cost involved there. So there's ways to address this, but at the same point in time, for someone new coming in, right, who just spins up something and they write some code, this could be an unexpected challenge, right, with cold starts and random requests and help desk.
Yeah, I think we can agree that this problem is smaller than on the beginning. It probably will be would be solved in the future by platforms, but we need to remember that it's still an issue.
Yeah. Yep. No. Yeah. Absolutely. And so you want to be able to say, if you get a request and you want to be able to say, oh, that was because of a cold start, or was this because of something else, right? And that's the challenge at play. If you get a slowness, what is the source of that slowness? Are you going to spend your time hunting around something that's a cold start that you can't do anything about, or do you actually have a platform issue, right? And so that's the kind of unexpected stuff with cold starts. Yep. Now, the next one is the big one, right? This is the one that will burn new people and seasoned people alike. And what this is downstream, right? So far we've been talking about code running in a function, right? But naturally code interacts with other things, usually downstream. Usually, for example, if you're using the API scenario, a UI posts some data to your API in Azure Functions, and then that saves it to a database, right? So we almost always have something downstream. It could be a database most commonly, but it could be APIs, third-party APIs, your own APIs, right? But the problem is that as your function starts scaling to meet demands, right? Let's think about those messaging scenarios, and all of a sudden 500 messages land in the queue, right? Because there's some batch process that just threw a bunch of messages in there, right? Now, in regular consumption plans for Azure Functions, that could mean as many as 200 servers all of a sudden spin up, right? And start processing these. Now, these 200 servers are running your code, right? That talks to your database or your APIs. And so what ends up happening is you start flooding your downstream, and your downstream can't scale necessarily, or you're not prepared to have that downstream scale as quickly as you need it to be, as quickly as Azure Functions can do. So Azure Functions in your code is rocking it, right? It's going along, but you're burning down your database. And that can become, this is a very, very common scenario, once again, for new people and seasoned folks alike, right? That Azure Functions and serverless start scaling and your backend can't handle it. Now, there are ways to deal with that. I'm not really gonna kind of get into some of the details of the ways you're dealing with it, but you really need to be aware of it, right? Because if you're going on a cheap Azure Functions and you're like, hey, this is only costing me, 18 cents a month, right? And you're trying to save some cost, you need a database. So you get a little database instance, a little SQL Azure instance, right? And you're paying the $15 a month for that has only so much capacity. But then all of a sudden, your Azure function starts spinning up because it's doing something, and the SQL database can't handle it, right? So you're going to be left with lots of exceptions, some throttling, some things like 429s. You may lose some data. All of those things happen when you don't consider the grand picture of how your data is flowing through your application, and that often happens with new folks to serverless, right? They don't expect that scale, and they don't think about the downstream. And they don't account for that. So that's one of those challenges. Adam, have you heard of those kind of scenarios?
Yeah. That's yeah, a lot actually. Yes, and additionally, so if you basically press your database up to the wall almost, you also can get those very freaky timeouts from the Azure Functions, yes, because you will actually starve some of them, yes, and they will actually not get a response, at all sometimes, yes. So you can actually get some false positive, yes. So you get timeouts from your code, but actually that's a database because it was not able to serve those clients at all. Yeah. So yeah, that's happened.
You're thinking it's one thing and it's actually something else.
Yes.
So it's challenging, and we definitely going to get here and do a second of how we can address those challenges.
Yeah.
But the last thing I want to mention, and this is something that isn't inherent to serverless, but very prevalent in serverless, right? So distributed asynchronous kind of communications, these distributed platforms, right, that do asynchronous common and messaging and things like that, right, are not universal to serverless, right? There's lots and lots of platforms that implement this type of pattern because it's a common pattern that allows you to scale, right? But it's very, very prevalent within serverless because you have to implement some of these patterns in order to effectively use serverless. Because once again, going back to that first issue, you can't do everything in a single function. You're gonna run into timeouts. So you want to break that up and distribute it. So to be able to really effectively scale. But so sometimes these units of work are chained together. Sometimes they're run in parallel. Sometimes they're both, right? Now I mentioned a little bit about this durable functions piece, which makes the development really of those complex orchestrations much easier. But what happens when something fails in the chain? What happens when you have a bottleneck, right? Those type of scenarios, which are very common, become very, very difficult to understand and track down. And so they will overall give you some challenges with serverless because we inherently are building those type of patterns and they are inherently a little bit more complex. We might be easier to write because we've got awesome things like durable functions, but at the end of the day, to be able to support them and understand how your data and how your data is being processed through this whole pipeline can be kind of hard, right? And especially when you're doing something as simple as durable functions that's translating to complex stuff behind the scenes, there's some challenges along the way. So these are some of the common challenges. Obviously, there's more, right? But timeouts, cold starts, downstream issues, and general complexity of supporting distributed asynchronous platforms are things that you might run into, right?
So I think that the good summary for those things we mentioned, Josh, is that it's all about architecture, understanding the concepts, and all the best practice we could use, because it's like, as you mentioned, we can DDoS our own infrastructure because we spin up pretty nice serverless function, and it works perfectly. Yeah, but it's killing our main system. So it's main app. So it's a challenge, and also reading the documentation, understanding the differences. There's a lot of things going on there. So learning, I think, from experience and from reading, this is also a good recommendation for people who are starting. So we could move to another part where we have one point. What is the single most important consideration for serverless? We have talks about it, so let's hear it, Josh.
Yeah. So and there are obviously lots of considerations. You were alluding to some a few minutes ago, architectural considerations, right? There's a lot of different considerations at play, but if we were to distill all of this down to one thing, what is the one thing really that is the most important thing that you should do, that you should consider, right? And really at the end of the day, that single most important thing is having the visibility into your application. That is by far the single most important thing, right? Because this makes a lot of those scary challenges that we were just talking about. I might scare you a little bit, say, oh, cold starts, and what about all this distributed async stuff? And oh no, how am I going to diagnose if this is going slow? All those scary kind of challenges, right? It makes them manageable, right? Because you have enough visibility, right? And with some luck, some predictability, right? To kind of identify and fix those issues quickly. That's finding that root cause quickly and identifying what you need to fix it is really half the battle. Going back to that same timer job, right? If you look at that timer job and you're processing what you expect to be 10 records, right? And so you have a big loop in your code that says, I'm going to process these 10 records individually, right? And one at a time. And all of a sudden you get 1,000 records in, right? If you understand inherently that something just blew up, but if you understand the root cause of it, oh, we went from 10 to 100 records, right? Or 10 to 1,000 records. and we're simply timing out, you know exactly what you need to do. You need to put a message, implement a message pattern, right? Dump something in the queue, let it scale out, right? You know exactly what you need to do. That is absolutely half the battle, right? So, but for many developers, when they think about monitoring and visibility, and I'm guilty of this, right? They think in terms of logging, right? So, and that's okay, right? We're all kind of coming from different foundational places when it comes to how we want to monitor our application. But for a lot of folks, it's just logging, right? I'm using, Log4Net, or I'm using just the baked in logging stuff. And I have stuff that made it here, log this exception, right? And that's definitely part of the equation. And that's an important part of the equation. But there's really kind of three real pillars of observability to be able to get the level of visibility I'm talking about. And logging is the first piece, but we also have metrics are really important. And of super important for finding root cause, right, is tracing, deep tracing, right? To be able to say, and this tracing becomes especially important as you start having some of these asynchronous pieces, right? So that you can follow the request through the process, whether it's a process in a single piece of code or if it's jumping between functions, right? So you can follow that around. That tracing becomes really, really important, right? So, but it's all of these metrics will give you insights into when things are about to die or what things are trending. The logging is going to give you very exact details about like exception information, and the tracing is going to give you how you got there, right? And where it's at, and be able to isolate things so you know what logs to look at, right? So all of this effectively manages a lot of those challenges that you'll get. And it really it's not going to fix those challenges for you. But once again, being able to quickly identify and isolate and find the root cause of whatever shortcoming you have in your code it is not only half, but probably a majority of the battle, right? Most developers understand if they look at something and they say, oh, this is how I need to change the code. But understanding, what you need to change, that's a whole different story. And that you can get through visibility. So I would categorize as the single most important piece, right, is monitoring and visibility, because it's going to mitigate all those other issues you have. And if you go in blind into this, and I can talk specifically from experience, if you go in blind thinking, I'm just going to write to logging, you'll have a potentially painful experience. You need the complete picture that those three pillars really give you. And so with that in mind, I think this is kind of a natural transition. I'll kind of hand this off to Andy, and he can kind of dive into some more detailed scenarios, some detailed examples of what that actually looks like in practice.
Yeah, thank you, Josh. Yes, can I steal your screen? Hopefully I can. Yes, I hope I was able to. Yes, exactly. So yeah, so just regarding what you said is lots of problems, like Professor said, the architectural design and the like. Lots of problems actually span out because we as developers hold some assumptions that actually are not true in the cloud native world. Yes, and when I was a long time ago studying at the university the distributed systems and networks, there basically like 10 or 11 the falsehoods the developers believe in, like that like the network is reliable, yes, like the response times are constant and the like, and observability can actually give us they can basically make us aware of those assumptions we made designing our system. Yes, so I will very quickly go through some of the examples of those things we have mentioned. So first I will just start with just troubleshooting, basically a full stack application, and this is the example that you want, one of the examples you have given. So I have a Vue.js, a static compiled Vue.js application deployed on Azure storage. There's no backend that hosts that application at all, but there is API on Azure Function that this application calls, and it's basically like a monthly reporting functionality. So let me just go to my RevDeBug screen when I monitor this application with, and so just very quick run out. RevDeBug basically becomes part of the application when you use RevDeBug. You just add RevDeBug as a dependency to the project and just it just ships with your project. So it might run as a Azure function. It might run like this static UI front-end application deployed in just basically a static web server or on premises or another cloud. So here I have this front-end application here, monitor. It's actually just a static web application. There's nothing that can go wrong there. But it calls the Azure Functions that I have deployed here. I can actually see some metrics from those functions. So basically, I have actually a couple of functions deployed behind a single Azure function endpoint name. So I have a couple of them and can basically look at those metrics. So for example, the cold starts are actually split from the normal usage because they skew the metrics quite a lot. We can see here, but I can see the response times from my Azure function. I can see the which are the most successful one, which are the most error nose ones, and which are the slowest one. So I can also be able to actually prioritize maybe some optimization there. But some of them are actually designed to show some of those problems we have. And this one of those Azure functions that the application calls is actually application that just collects some data from live sales database. So there is a Cosmos database there. It processes this in a loop, like you mentioned, and it puts the output to reports, a database, a separate database that basically is made for the report. So besides the metrics and the response times, the service level of our application, of course, RevDeBug can also show the traces, yes, and actually the very deep traces of what went inside the application that, for example, that it broke. So going, for example, for the first error here, I can see that there are two parties responsible, like I said. So the static UI and the Azure function here, and they are color coded. Yes, they are color coded. You can see that this is the part from the UI, this is the part from the API that it was called, and there was of course an error. So I can see, of course, the logs from the error here, some timestamps and the like. But with RevDeBug, I can actually delve even deeper. I can actually see the code that was executed, and even if this code actually is a compiled release code. Here actually it's a Node.js, but it was actually minified before that. But still, we get the recordings of what happened there, and I can actually go back in time with this recording, like step by step, yes, using those arrows, and I can see just what happened there. Yeah? So here actually, the error is that there was no records processes. I can actually jump here on this event list to see that actually it puts some database to the reporting database that I see already that actually I made an error. This should be error. Yes, we shouldn't actually insert when there is no records process. And actually, I can go to all of that data that is, for example, here processed in the for loop, and I can see why the processing, basically the condition that process the data haven't been met. And just to make it quick, I will just search for this through this recording for this mean value to see what actually how it was set up. I can see that it's quite actually large, and I could right now also query for normal values to see which one was pressed. But just to cut the story short, I would just jump to because I see that it was passed to the function from the UI. So let's see what actually happened on the UI. So what happened on this JavaScript Vue.js statically deployed application. And I can actually look at the source code and the execution of the source code there as well. And if I will just jump to this point of time, I can see that, and here at the code, I can actually see that we actually have made an assumption with this application that the user will enter the units in the amount in thousands, yes, but probably the user entered the the 1,000 with with the 1,000. Yes, and additionally, of course, because we have the recording of the source code, but we also record actually the DOM tree changes from the website, so I can actually see what the user was doing when he was doing that. So I can see that, oh yeah, so yeah, he was trying to enter something, and yeah, he entered those 25,000 here. Yeah, so here we have basically a user error, or more explicitly, I can actually call it a UI error, because we haven't communicated with the user in the right moment. But I was able to, with this tracing and monitoring of this application, very easily troubleshoot, yes, debug the application and see where all those values came from, why they landed where they landed, and I can go basically through the whole stack and the like. And maybe additionally, if I would like to actually show you also one more thing, because I would like to reference the cold start. So and maybe this example will do. Yeah, so of course we monitor the application starts and the like, so we also can report the cold starts. So the moments when the application, the Azure was spinning out the Docker containers with the Azure function runtimes, and the Azure function was launched. So for example, here we have a cold start. Yeah? So we have the UI application, but the backend, the Azure services were not running. So we have a cold start, and we can actually see as the call on the JavaScript side started here, and basically the Azure function was ready here. So we have like a 5 seconds delay in this example for this cold start. The second time actually was much faster, but strangely enough, the function was actually running longer. Yes, so the overall times were actually quite similar. But those are those cases, and sometimes those can point to some optimizations things. But actually, I wanted also to show one of the anti-patterns that sometimes when you rewrite your application or remove your applications from on-premise legacy data centers to cloud, that can happen. And also how monitoring can show you that you probably should do something here. So here actually I have an example of Azure function that is called by some timer, and it calls a second Azure function. So I have a check data integrity endpoint, and it just at the end it calls the post data check hook, and it also runs for some time. Yes? So here I can see that the first function is calling this second function, but it is waiting, for this call. Probably it doesn't need to, if I can judge from the names. And here is actually a perfect example of how to use, maybe to use the durable function. Yes, because right now I'm actually paying for this wait time. Yes, I'm paying for this memory used for the Azure function here that probably is not doing anything, just waiting for the input output, yes, for this call to end. And using the reliable function, I could actually design a state machine that will just run this part of code and will just end this execution at all. We'll pass that execution to the second function, and if I need to get some results, we'll actually resume this execution and pass that state here. So also, as I mentioned, monitoring the visibility can give you the knowledge about those assumptions developers or we have made in the code, and to be able to make a judgment on yes, whether it is what we should do from the business point of view, or maybe we should actually change that. And just last thing, just to add a last thing, and of course for the UI part, you can actually see also logs from the client, yes, from the web browser, which is in most cases very hard to get, because most of the users don't know that there's something like a JavaScript console in the web browser. And for the databases, also seeing the response times from the database, how this affects the application, how it goes can also be useful, as we mentioned with Josh earlier. You might get some timeouts in the in your functions, in your Azure function, but actually the underlying downstream might be the issue. So you can actually also see that when you monitor. Okay, so that was, I think we are actually run out of time. So that was the very quick rundown of some examples I had.
Yeah. So just to sum up, we saw what is the best way to approach servers on the beginning. So Josh mentioned that it's a way to bring a velocity, and one thing to your development. And one thing you need to remember: you don't manage your infrastructure. This is the value, because if you don't manage the infrastructure, you could focus on delivering the code, the changes. Another thing is the challenges. There are few. Understanding the differences between platforms, languages, and specific functions or services. It's important, knowing the patterns. And we also mentioned that monitoring, it's really important. Without it, we don't know what's happening. And there are a few ways you could get this up and running. And at the end, Adam showed most of those things. I think we talk about the cases, what are the common ideas, how to use information from monitoring, so logs, traces, metrics, and understand what are the differences and why our code could have issues. So I have we are running a little bit of time, but I have just few questions we want to follow up, I think. So I have one that could be interesting for you, Josh. So one moment, I saw it. So what is the difference between serverless and Kubernetes?
Yeah, so we get this all the time, right? So Kubernetes is obviously very popular these days. So Kubernetes is a container orchestrator, right? So it's all about a platform that is intended to run container-based workloads, right? Now, serverless, interesting enough, and where things get a little confusing and a little crossover, is that serverless platforms such as Azure Functions can run in containers, but they're not a container orchestrator, right? So think of a container as just it's a deployment mechanism, right, for your code. Now, in general, when you're talking about Kubernetes, it's the underlying infrastructure. You still have to manage it, right? Now, cloud providers do a little bit of a management layer for you, and it gets easier than running your own, but it still requires infrastructure management. It still requires, in general, for you to designate, hey, I need 10 servers, I need 10 VMs, right? Oh, here's my pool of 10. So I generally categorize Kubernetes, at least Kubernetes in the cloud, as more of a PaaS platform, which is like platform as a service. So it's like the next step before serverless, right? Yeah. Where you're not necessarily managing as much, but you still have a lot of responsibility. And for the most part, my recommendation for folks are, and I'll add one little thing into the mix as well. You can technically run Azure Functions, the runtime, in Kubernetes. So you can deploy your Azure Function to Kubernetes. You're not getting the serverless piece, but you can run your Azure Functions code in Kubernetes. And so that's an interesting opportunity for folks who are concerned that, hey, I want to take advantage of serverless. I want to write my code, but what if we have something on-prem and I only can run on-prem? What do I do then? Do I have to rewrite this code? And the answer is no, right? But in general, obviously serverless is just a step up above that. It's fully managed as opposed to kind of partially managed. And interesting enough, the last thing I'll mention on that too is that Kubernetes is kind of slowly evolving and growing more towards the serverless side. Yeah. So there are actually serverless elements that you can introduce into Kubernetes that muddy the waters even more, right? So there are platforms on both AWS and Azure that are essentially serverless container platforms. So those scale containers to meet your needs. If you add that to Kubernetes, you could argue that you have a serverless Kubernetes platform. So It's definitely it's a foggy line, right?
Yeah. The lines are blurring. Yes.
Yeah.
I would just maybe add one more thing. So if you deploy your application in Kubernetes, you still have to containerize your application. You have to put it inside the container. With serverless, you just write this function code. It's all automatic, it's fully managed, like just mentioned. Yeah. So this part of managing those containers and managing, how they should scale, how the running updates should go. That part is fully managed. You don't have to care about that at all. Yeah.
So, as I understand correctly, I could write my Azure functions, running them on Azure, and there is a way to solve issue with vendor locking, and I can get something from Microsoft to run it, to run Azure functions on my another environment, another server.
We've had customers that have used Azure Functions because they had to. It wasn't their first choice, but because they had to, running them in AWS. That kind of blows from people's minds. But running in Azure, they had Azure Functions. They made their investment, and they ended up having a workload they had to run in AWS, and so they put it on a container in an Azure Functions runtime, and it's running on AWS. So ironically, but once again, that the distinction here, however, at the end of the day, is that you still have a lot of responsibility that you have to take care of when it comes to Kubernetes, right? You don't have necessarily the velocity. I still have to worry a lot about infrastructure. I still have to worry about how I do deployments, the complexity with deployments. Even if I want a serverless-ish Kubernetes, I have to configure all that. I have to manage all that. I have to do all that, right?
It's all about
effort's greater.
It's not serverless. It's managing infrastructure. It's automated, but it requires some knowledge and could be problematic. So,
but much easier than it was, but still, yes, you have
correct.
When it doesn't make sense to use serverless.
Yeah. So from a serverless perspective, it depends on what your goals are. Now, I'll give one example. For many customers, it's the cost, right? It can be cheaper, right? Especially if you have very bursty, unpredictable loads, right? That are really hard to optimize on traditional servers, on traditional VMs. The one area where you may pay more for serverless, as great as serverless is, and a big advocate is, the one area where you may potentially pay more is if you have a highly predictable workload. You know that there's going to be 10,000 requests every hour, consistently every hour, and this is how you have to scale. Generally speaking, from a cost perspective, sometimes you can get better cost optimization if you have a very consistent workload. You will pay more in general for serverless because you're getting that benefit of the variable nature. But if you have a highly predictable workload, right, then you can do some cost optimizations where serverless from a cost perspective doesn't make as much sense. But it is worth mentioning that that's definitely the minority of workloads. Think about most of your workloads out there, right? They're very unpredictable, right? They're based on random user events, right? User utilization. But once again, where it doesn't make sense, the other place where it doesn't make sense is exceedingly high latency operations. We talked about those cold starts, right? You can do some things to manage those, but if you're doing, for example, I don't know, stock trading, right? Where you have to be down to or medical equipment, something medical, right? or something that latency means death, right? Or latency means huge loss of revenue, things like that. Those because of some of the inherent aspects of new instances spinning up and things scaling for you, you won't always have very tight latency when it comes to serverless. So those are a couple of things that come to mind. But once again, I think I go back to, most of the workloads out there aren't that latency sensitive, and workloads out there are very variable.
Predictable, steady workloads. And
if I might add, so some people I worked with, they get actually bored, but it was some time ago because of those cold starts, because they actually had a very rare, not bursty, actually, just rare usage of some APIs. But those cold starts added so much latency than these very rare usage was in most cases ending with timeouts. Yeah, so they had to add, like, just like you mentioned, some some triggers, timer triggers to keep those APIs hot. Yeah, but they get actually burned because of that. Is because it was, when I am testing, it works perfectly, but and tomorrow morning I get an issue, like you said, yes, that it doesn't work. And
the first person coming into the office,
exactly,
right?
yes, and if it's rare enough, you can actually get this issue each day in the morning.
Yeah. And usually the first person coming to the office is the CEO, because he starts.
Exactly.
It never fails.
The worst case scenario.
It's the worst case scenario. Yeah.
Yeah, but if you keep this in mind, and it's got much better now. Yes, that it was. Yeah. So but if you keep this in mind, you can actually get that working. And it's very easy to start with, because you don't have to care about this infrastructure. You just care about the business logic.
That velocity, absolutely.
Yep. Yeah, I have last questions because we are out of the time. Josh, you talk about 3 pillars of monitoring, observability, visibility, like logs, traces, and metrics. Why we can't fix issues when we have those informations? What we are missing?
Yeah, so at the end of the day, right, it kind of goes back to one of those challenges around distributed asynchronous, right? And if you've got, it's very rare these days that you have just a single process running and doing a single thing, right? And at the end of the day, you need to quickly identify where in a pipeline an issue is occurring, right? So, and using that as an example earlier, you could have a database issue, but it pops up in the UI and you think you got something wrong in the UI, right? And unless you have that complete picture, you're not going to be, at the end of the day, it really comes down to, I'll use a big a monitoring term, MTTR, mean time to resolution, right? Yeah. It's that ability to, once you have identified an issue, whether it comes in through an alert or it comes in through a user, how fast can you identify the root cause? And without those 3 pillars, that length of time could be significant. It could be measured not only in hours, but days or weeks, right?
Yeah.
And I've seen and experienced months, right?
Yeah. Yes.
And it's that weird issue. So at the end of the day, if you distill why you need this at the end of the day, is you want to avoid those days, weeks, months, right? You want it right away. And if you just have one slice of that pie, if you just have metrics, you'll know there's an issue, but you don't know what it is. If you just have logs, you have too much information. You can't figure out what to look at because you're overloaded with information. If you just have traces, you might not have the level of detail that you might get from logs by looking at the traces, right? So you need those 3 pillars at the end of the day to quickly identify the issue, and to get the benefit of serverless, that velocity. This all comes back down to that velocity, right? To get that velocity, you got to find issues quick. And if you're not using all 3 of those pillars, I guarantee you will not find issues quick, and you will spend more of your time trying to find the issue as opposed to building new features, right?
Yeah, exactly. Yes, and if we can share some horror stories, we actually with Piotr, we had some experience with clients, that for example had application that basically run 24/7, but the errors actually happen mostly at night. So what you have, if you don't get this information stored, you get night shifts for developers, which it's not a pleasant thing. Yes.
No.
So
everyone works in the same time zone.
Yeah,
this is the issue.
and
if you have distributed team, you could cover it.
And if you don't, and if you actually can't fix that in months, like you said, what happens? What we do as a developers, we do workarounds. Yes, we just we try to fix the bad situation, but that's actually a different name for a technical debt. Yes, it stacks in years, and then after 4 years of such a development, it halts. Development halts because no one actually understands this code anymore. Yeah, so
that technical debt's an important thing. When you can identify issues quickly and not incur that technical debt, that becomes very meaningful over time.
I remember one thing: the debugger in production and closed computer for the weekend.
Yeah. So yeah. So
Friday deploys.
year ago actually we well, the developer actually was, because the case was, so they didn't have the observability that they confronted, but the developer actually connected a debugger, the production system, because he was totally desperate. He wasn't actually able to find the issue, but he left the debugger actually running when he stopped the job. And
he probably had a break
of course
point
was
in there,
hitting, and everything. The world stops for everyone. Yes, worst case scenario.
You don't
Worst case
know.
scenario.
You don't know why it's not working.
You shouldn't do that ever. Yes, but sometimes we are desperate. Yes, so that's why it's important to actually get this data and be able to validate those assumptions we have as a developers. Yes, and we always have some.
Yeah, I think that's a great summary for talk. Sorry for making it a little bit longer. We had some troubles, but
apologies for my network issues. I haven't had an outage in like 6 weeks, and of course it started like what?
Josh, don't
5
worry.
minutes in.
Don't worry. I think that the talk was interesting. The recording will be live in a few days. We also send few links so folks can start. If you have any questions, you could get to Josh via Adam via Twitter and LinkedIn. So Josh.
And I have open DMs on Twitter, so I have open DMs. So feel free to connect with me, either one of those areas, and happy to have some conversations. I always like talking to folks in the community.
Yeah. So if you have any questions, if you want to follow up, if you want to send this webinar to your friends, to your colleagues, just feel free to do this. And Adam, Josh, thank you for today. It was a pleasure. Hope to see you soon. Okay. Thank you.
Take care, everybody.
Yeah. Bye.
See you. Have a great day. Bye.